warm good morning, my dear students. Welcome to this chemistry digital class. And as we are doing nowadays our unit 8, that is D and F block elements. So yesterday in our last video we have finished our D block elements, in which I have told you about some important compounds of D block elements also, that is potassium dichromate and potassium permanganate. Hope so you understood that video and you like that video. Now I'm going to move with the next part of this chapter, that is F block element. Dear student, as you know that the F block element is the fourth important block in our periodic table, whereas if we will talk about periodic table, so there is S block, then D block, then P block, then in the last, in between the D block, there is 14 different groups elements of two period. These are F block element. Okay, so let's start. It is written here that n minus 2, you can see here it is written here n minus 2 F. What does it mean? It means that as in the configuration D was n minus 1, n mean principal quantum number, okay, the number of period, that minus 1 is starting the D block configuration. Now for F block configuration the n minus 2 is there. It means that we need to subtract 2 from the number of period. Okay, like suppose if element is present in front of 6, so we will make 6 minus 2. It means that 4F will be the configuration of that particular element. Okay, so in the introduction of F block element, let's see what is the introduction of F block elements. As you know that D block elements are known as penultimate. As you know that D block elements are known as penultimate configuration या penultimate elements where n minus 1. So similar way F block elements known as pre-penultimate, that is n minus 2F. Okay, so it is also famously known as inner transition element because electron use is both shell. Electron use is both shell, D shell also, F shell also. Because of that it is inner transition elements. Next is intermediate behavior, like D block elements mean intermediate behavior mean it is showing like the dual behavior in between the S block and P block. It is present in between S block, P block also with D block, so that's why intermediate behavior. It has two series of F block. It means that total 28 elements are there. In one series 14, the two series 28 elements are there. Basically lanthanum series या lanthanide series is our main topic that we will study in this chapter. Actinide series are radioactive, that is not that much in detail in this chapter. Okay, so this was the introduction of F block. Now if we will talk about the basic elements of lanthanum series, so we have basically lanthanum 57 to, you can see 57, 58, 59, 60, 61, 62, 63 up to 71 lutetium. Okay, so these are the basic elements that is present. Now whereas the name, if we need to learn, so I'm telling you that is, this is lanthanum, this is cerium, this is praseodymium, praseodymium, it is neodymium, it is promethium, it is samarium, it is europium, it is gadolinium, it is terbium, it is dysprosium, it is holmium, it is erbium, it is thulium, it is ytterbium, and it is lutetium. Okay, so in the end if you will see the suffix, it is coming em. Okay, E-I-U-M, em, the lanthanum, cerium, emium. Okay, so these are the basic feature that the end of lanthanide series elements are with IUM. So EM word is coming. And secondly, if I'll say there are 14 elements which is called lanthanide series. In general configuration, if we write 4F1 to 14, 5D0 to 1, 6S2. Okay, 6S2. There is S2. D, you can say D is not 1 to 10 here. Why? It is here, you need to take care. This thing is need to be note down. This was, if you will talk about the D, we will talk about the D. Okay, so D, in this D particular, let me zoom this little bit. Okay, so this is particular D. I'm talking about this configuration. So 4f is why, because it is in front of 6 series, 6 period. So you know n minus 2, so minus 6 minus 2, there is 4. That's why 4 is there. F14 is there in series, so F1, F2, F3, like this way, F14. So if we will talk about 5D, 0 to 1. Dear student, this need to be take care, this 0 to 1. Why it is not D1 to 10? Because the F block is present in between D1 and D0. Okay, so that's why it is 0 to 1. This is not like a 1 to 10. So this is all about the lanthanide group. Now one by one, small brief, we will see where it is used in our daily life. So in lens camera, lanthanide is used in lens camera. Lanthanum, rare metal, rare earth metal, which is used in camera lens amongst other things. So lanthanum is found in uranium mineral. Okay, so this is one. Second, cerium is used in sparkling light, also used in permanent magnet. Okay, so in lighter also cerium element is present. So next is praseodymium. Its configuration, if I'll say, so it is a 4f3 5d 1 5d2, yes, 5d 1, sorry, 5d, no sorry, it is 4f. The configuration of praseodymium is 4f3 5d1 6s2. Okay, so like this way. So it is used in aircraft, the fighter jet. Praseodymium is used in the satellite, that you can say telescope. Okay, and next is neodymium. It is used as a fertilizer, or you can say the insecticide. Neodymium, it is a strong magnet also. Okay, that is a 4f4. Its atomic number is 60. This atomic number of this element is 60. Z is 60. If I will tell the its configuration, it is 4f4 and 6s2. Okay, rest 5d is 0. So this is neodymium. It is used in the strong magnet. Neodymium, again, it is used in strong magnet of headphone also. Europium, it is next. Europium is used in the bulb, whereas europium 63 is the atomic number, 152 is the atomic mass. Okay, and you can use it, you can see it is used in LED also. Europium is used to produce blue, red and white radiances in computer monitor and television screen also. It is also used in energy efficient light bulb also. Next, what is the position? So these were the basic uses, and now if we will talk about the position, this is S block, this is P block, we have already done. D block, this also we have done. Now we are doing F block. So position of F block is somewhere in between the D block, where is third group of D in front of 6. Okay, so in front of 6 period and below third group there is F block, which is present inside the D block. That's why it is called inner transition elements. Okay, same chemical physical properties are there. Total 14 elements are there. Same number of balances are there, 5d1 6s2, but 4f is 1 2 3 4 5 6, like this way. Okay, so you need to see. This is next. And electronic configuration of lanthanide, if I'll say, the electronic configuration is based on Ofo principle, whereas lanthanide is 57. So xenon is the last. Xenon is the last noble gas, so we will write first xenon 54, then after that we will write 4f02 4f14. Okay, so this is the configuration. It is observed electron configuration is not true for all the elements. Some of the elements it is just recognized. Okay, so after electronic configuration, if we will talk about the electronic configuration of proper lanthanum, so you just take screenshot of this video, this page, and just write down these electron configuration. Okay, if we will see, though very seriously, 4f1 4f2 is not there, 4f2 is not there, 4f3 is there, 4f4 is there, 5 is there, 6 is there, 7 is there, 8 is not there, 9 is there, 10 is there, 11 is there, 12 is there, 13 is there, 14. Now in place of 2, where is there? That is 5d1. Okay, rest 6s2 is there, so 5d is somewhere 2, so 54 plus 57, 58, 59. So presidium is somewhere 58. Okay, so like this way configuration is written. So you just go through once. If next property of lanthanide is oxidation state, common oxidation state is +3, which is more stable, and it loses of 2 6s electron and 1 5d or 4f electron. That's why the configuration is mostly found in +3, because 1 electron, 2 electron lose from 6s electron, 1 electron lose from 5d or 4f. So total it is 4. Some either show +2 and +4 oxidation state also, whereas lanthanum to lanthanum 3 positive, if I'll say, so how it is. So these elements have +3 oxidation state, these elements have +3 +4, and these elements have +2 +3, and these elements have +2 and +3. So you can see most of the element have oxidation state +3, but some of the cases there is +2 and +4 also. So you need to learn where is +2 and +4. Okay, next is chemical reactivity of lanthanide. This question so many times that question can ask in exam. So lanthanide chemical reactivity is there when it burn in the oxygen. When it will burn in the oxygen, it will give us lanthanide oxides. Okay, when it will react with acid, it will give H2 gas like other metal. When it react with halogen, it will give halide with 3. It's I'm telling you oxidation number is 3, so it will give 3. Okay, here 3 atomicity if oxidation state is 3. Then when it react with H2O, it will give us hydroxide with H2 gas. If it will react with carbon, it will give carbide. It will react with nitrogen nitride. It react with sulfur sulfide. So dear student, very simple reactivity series is there. What is given in this periodic table, so you can learn from here. Okay, in this chart you can learn from here. You have to draw like this way also. What very simple, suppose if I make a lanthanide will react with oxygen, so it will give Ln2O3. Okay, it means that here 2L, here it should be 3, so here 2 to the 4, so here we will write 4. Okay, so like this way we can make the reaction. Next is chemical reactivity of lanthanum. The first few members of the lanthanum series are quite reactive, and it shows chemical behavior similar to that of the calcium. In the case of calcium also there is 2 positive charge. In the case of lanthanum also 2 positive charge. It means when it reacts with oxygen, calcium will also give Ca2O3 or Ca2O2, and lanthanum is given CO2O3. Okay, so this is the similarity between calcium and lanthanum. The standard electrode potential of lanthanum is Ln plus 3 to Ln, which couple indicate that all the lanthanide are more reactive than aluminum. Okay, these metal combine with hydrogen when heated gently in the gas and give lanthanide hydride, lanthanide trihydride. This is also chemical reactivity. Then next chemical reactivity in series, that is lanthanoid. When react with hydrogen, it will give hydride. Okay, in case of, and when it will react with oxygen, it will give oxides. Similar way, when water, it will give hydroxide, and with carbon dioxide, it will give carbonate. So next is chemical reactivity of lanthanide with carbide. With carbon at 2773 temperature, it will give carbide. With nitrogen, it will give nitride. With sulfur, it is giving sulfide. It is not that much difficult. A very simple reactivity is there. So you just have to note down and just learn it. If it will react with water, it will give hydroxide. You can see here, and water. It liberates hydrogen when we are going to react it with dilute acid, yeah, HCl or something. Okay, so it will give hydride. It made hydride. Sorry, it made halide and produce hydrogen gas like other metal. When metal react with acid, it will again producing hydrogen gas. So dear students, one very important topic or very important questions are coming, that is lanthanide contraction and its consequences. This question you need to note down in your book also, and it is very important, I am telling you, as your examination point of view also. So note down what is lanthanide contraction and consequences. Okay, so basically lanthanide contraction is what? It is the gradual decrease in atomic and ionic size. It is the gradual decrease in atomic, decrease mean down, gradual decrease in atomic size and ionic size of lanthanide with increase in atomic number. जैसे जैसे एटॉमिक नंबर इंक्रीज होता है 57 से up to 71, it means that the atomic size will decrease. Now what is the reason? You know, down the group atomic size is increasing with the increase in atomic number, but in lanthanide contraction atomic size is decreasing with the increase in atomic number. What is the reason? So this thing basically is known as lanthanide contraction. Contraction मतलब contract होना, छोटा होना. तो lanthanide की सीरीज जो है वो contract होती जाती है जैसे जैसे हम atomic number को बढ़ाते हैं. There are some causes. As atomic number increases, the positive charge also increases in the nucleus. Because of that positive charge in the nucleus, the size of the nucleus is becoming bigger and bigger. It increases, but the outermost shell remain same. So as atomic number increases, other thing decreases. Suppose other thing are what? Atomic radius will increase, ionic radius, which is greater than the screening effect. Now what is screening effect? It is the same effect that shielding effect we have studied. Okay, so the effect of lanthanide contraction, it decrease the basicity also. Mean basicity is basic. That is called Fuzzen's rule or Fuzzen's principle. So sometime question is coming, what do you mean by Fuzzen's principle? So you need to write that effect of lanthanide contraction decreases the basicity. That is called Fuzzen's rule, where larger the size of cation, greater is the tendency to such hydroxide to dissociate. Okay, like larger the size of cation. Lanthanide have greater size than lutetium. So lanthanide have greater tendency to form hydroxide and to dissociate the hydroxide into OH negative ion, which is with the weak bond, and strong will be the basicity because it causes the covalent nature. Because of that it decreases the basicity. That process is called Fuzzen rule. So basically the main cause of the lanthanide contraction that we have studied is as atomic number increases, the positive charges also increase. It can be that as we move through the lanthanide series, basically 4f electron are being added. When 4f electron are being added, then what is happening in each step, the mutual shielding effect of electron is very little. Shielding effect of electron is very little, even smaller than that of d electron. In d electron also their shielding effect is there. Similar way in f block also there is shielding effect. Okay, and what is shielding effect? Now it is the effect that is caused from nucleus. Suppose you know that number of shell is increasing, so here is electron, here is electron, here is electron, here is electron. So if in 4f there is electron, this is 4f, suppose this is 4f, this is the shell of 4f electron, so that each electron is shielding the nuclear charge to this electron. So this electron is easily going to be dissociate, going to be removed, going to take positive charge. The more the cationic charge, okay, more will be the bond dissociation, you can say the charges, okay, greater will be the charge. So even smaller than of the d block. This is due to the shape of f orbital also. The nuclear charge increase by one of each step, hence the inward pull experienced by the 4f electron increases, and this cause a reduction in the size of the entire 4f shell. The sum of the successive reduction gives the total lanthanide contraction. So consequences are, it has very important effect on the relative properties of the element which follow the lanthanium with those which precede the lanthanide. It means that we know that there is a regular increase in size as we go from scandium to yttrium down, and to lanthanide also. Mean scandium is here in fourth, in front of 4 series, in front of 5 is yttrium, and in front of 6 is lanthanide. So mean size is increasing gradually when we move down the group. Similarly, we expect that normal increase in size in other group also, which is second after scandium, zirconium, which is after titanium, vanadium, zirconium, niobium. However, after lanthanide, the increase in radii from second to third transition series are vanish here. Okay. So because of that, lanthanide, the increase in radii from second to third transition series is vanished, and consequences the pair of element zirconium, hafnium, okay, that niobium and tellurium, or molybdenum and tungsten, these have almost same size. Okay, because of increase in F shell, the down the group there, that the which is element in the fourth series, fifth series, and element in sixth series have almost similar size. That is called lanthanide contraction. So now effect of lanthanide contraction is again, if I will talk in detail, the ionic radii of post lanthanide also. The element which follow the lanthanide in the third transition series are known as post lanthanide. पोस्ट लैंथेनाइड में लैंथेनाइड के बाद आते हैं, ये कहाँ, थर्ड सीरीज के बाद. द आयनिक रेडियाई ऑफ द एलिमेंट विच फॉलो लैंथेनियम लाइक होपनियम, टेलेरियम, टंगस्टन आर सिमिलर टू दैट द एलिमेंट ऑफ प्रीवियस पीरियड विच आई वाज टेलिंग. देयर इज नॉर्मल इंक्रीज इन साइज ऑफ स्कैंडियम टू यट्रियम टू लैंथेनाइड. Okay, so lanthanide contraction, if I'll say consequences of lanthanide contraction, so basically lanthanide contraction, this is because these are similar number of valency and properties are called chemical twins. Those elements which have similar type of properties are called chemical twins. Suppose if we will talk the groups, series and periods, suppose in group 4, 5, 6, 7, we are talking about group 4, 5, 6, 7. We are not talking about scandium. Then after scandium, hopnium is there, then lanthanide, scandium, yttrium is there, then lanthanide. We are not talking about this. We started from the fourth. Titanium, 132 part meter is that 5, 6 in group 4. Okay, titanium, zirconium and hopnium have this variation in size. Vanadium, neodymium and tellurium have this size. Similar with this is, and similar with this is. So there is a marginal difference in the atomic radii. That's why the number of valency is also same. That's why these are called chemical twins. Okay, so this was all about the F block lanthanide series, dear students. Now actinide series left, that I'm going to do in tomorrow's video. So hope so you understood whatever is there, but basically only theory is there, but some of the logical questions that can be asked, and basically what type of question are coming in the exam, just note down, and you need to write down those questions also and send it to me. Okay, so question is posed, what are lanthanide? This question can come. Why F block elements are known as inner transition elements? Okay, write the general configuration of F block elements. Then why are lanthanides called inner transition element? That I already told. Then next question can come, what are different oxidation state exhibit as lanthanide? Like commonly +3 the oxidation state, but some of the cases there is +2 and +4 also. Then explain why lanthanide and GD and L lutetium exhibit only +3 oxidation state. What is lanthanide contraction? It is very important question. What is lanthanide contraction? What are its causes and consequences? Okay, so just I have told you last 3-4 slides. You just take this question which I am going to. Lanthanide contraction, causes and effect mean consequences. Okay, this you have to do. Lanthanide, sometime question is coming Y type. Like, why is separation of lanthanide element different? Lanthanide hydroxide is more basic than lutetium hydroxide. Why zirconium and hopnium have similar property? Why are the properties like atomic radii of third transition series very similar to second transition series? This is the answer. This is the answer. Which slide is there? And one important question is coming. Differentiate the lanthanide with actinide on the basis of its similarity and differentiation. That we will do in the tomorrow's video. Okay, so this is all about for today. Hope so you understood whatever I taught, and you liked the video, and you understood the topic. Now dear students, please watch this same video 2 times, 3 times, and after that try to prepare your own video and wait for tomorrow's video, that is actinide series. Then tomorrow the chapter is finished. Okay, so thank you. Have a nice day. Take care. Stay home. Stay safe. Thank you.